Math HiSet Secrets Part 4, Choose Your Own Number. There are certain types of problems where you can actually pick numbers to replace variables or to replace numbers that have not been specified in the problem. There are some geometry problems that can work like this. There are problems that involve fractional amounts. We'll try to find some examples of each of these. But the easiest and most obvious way to apply this is when you have some algebra and the answer choices are also answers that have variables in them. They're not just plain old numbers. And in those cases, you can pick your own number, pop it into the original equation, take the same number, pop it in the answer choices, and see which one works. Let's take a look at one like that right now. All right, this problem asks us to factor an expression. And if you know how to factor expressions, go for it. These techniques are specifically when you're running into problems you don't really know how to do, although you could use this technique as a way to check your answer. So keep that in mind. But meanwhile, here is how you recognize when you can choose your own number. So we have an expression here. It's not asking us to solve anything. There's no equal sign. So there's variables up here in the question, and the answer choices are also composed of variables. They're not asking us what number does this equal. They're saying which of these is the same. Now, if you haven't done any factoring whatsoever or don't remember, let me just make it explicitly clear that when you factor an expression, you're going to get an expression that's the same as this. It's just written in a different way. So one of these is equivalent to this, and it's much easier to see when we use a number rather than these pesky variables. All right, I don't know if that was clear. What I'm going to do instead is go ahead and pick the number and then show you how I use it. Now, I'm not going to pick 0. 0 might work in this case, might work just fine, but 0 often makes strange things happen in math, and it might make more than one answer choice work more often than other numbers you pick. So I kind of stay away from 0, kind of stay away from 1. They might work in this case, but if you were ending up with, if there was something with fractions or something, a lot of times 0 and 1 are just going to be a problem. So I'm going to try 2, and I'm rewriting the expression, and I'm just going to replace every x with a 2. A lot of times people will ask, why 2? Where'd that 2 come from? I picked it. It's my number. Could have picked any number. It's just nice and easy to work with. One student thought the whole thing was just magic, that no matter what I plugged in for the x up here, as long as I use the same number for the x's down here, I'd get the same answer choice every time. He just wasn't quite getting that the answer choice is going to always equal the expression up here because they are two ways of writing the same thing. Okay, so quickly, you'd have a calculator. You'd probably be done before I am. I'm going to quickly do this in my head. Let's see, 2 cubed is 8 times 2 is 16. 2 squared is 4 times 10 is 40. And it's going to be a negative number. 12 times 2 is 24. So 16 minus 40 is negative 24, and then minus 24, negative 48. All right. Now, if you're not great with negative numbers, well, that's why you have a calculator. I don't really know off the top of my head how large a number I would need to pick to keep it from getting negative. This is cubing it. This is only squaring it, and rather than waste time trying to keep it positive, I'm just going to let my calculator do the work. And before I try out any of the answer choices by putting a 2 in, I'm going to look at the answer choices and see if I can eliminate some, because my answer choice here, my answer that I got is negative 48. I'm going to plug in 2's up here for each of these x's, and I have to get negative 48. And right off the bat, I know that can't happen here because all of the numbers will be positive that we're multiplying together. When you add 6, when you add 1, when you multiply by 2, all of those are positive. 3 positives together, multiplied together, can't be a negative. Same for D. I don't even have to try those. And it gets better. This answer choice right here has an x minus 2 in it. 2 minus 2 is 0. So if this part is 0, this is going to be 0 times something times something. It doesn't matter what those two things are. Anytime you multiply by 0, it goes to 0. We only actually have 2 answer choices to try. So next up, I'm going to try this one right here. Just follow along. I'm just going to do this quickly out loud. 2 times, remember we're replacing x with 2. 2 times 2 is 4. 2 plus 6 is 8. So 4 times 8 is 32. And then 2 minus 1 is 1. So this is just multiplying times 1. So this becomes, actually this ends up staying positive because even though we have a minus here, it's not subtracting enough to make it negative. But anyway, it makes a positive 32. That's not what our answer choice is. So this one doesn't work. Now, if you were out of time, you could just move on. Pick this one and move on. But obviously, it makes more sense to quickly try this one as well and just make sure it gets that same answer. 2 times 2 is 4. 2 minus 6 is negative 4. So 4 times negative 4 is negative 16. And then 2 plus 1 is positive 3. Negative 16 times positive 3, negative 48. So without really knowing how to factor, we do know which of these expressions is the same as the one in the problem. It's A. And I guess this would be a good time to explain what I mean by don't use 0 or 1 because they make weird things happen sometimes. In this case, I do think 1 works, but notice if I were to have used 0 for x, first of all of these would be 0. This would be 0, minus 0, minus 0, so the whole thing would be 0. But notice each of these answer choices are 3 things multiplied together. And one of those 3 things is 2 times x. If x was 0, then every single answer choice would be 0. We would have eliminated exactly nothing. So stay away from 0, be wary of 1, but pick nice easy numbers like 2 and 3 to work with. Here's another algebra example. Which of the following expressions is equivalent to? Equivalent just means they're the same. So I can plug in a number, in this case I can plug in a number for A of my choosing, and since we're taking something to the 6th power, it better be a small number. Again, I could try 1, but that might make weird things happen, so I don't want to do that. And then I'm going to get a number here, and we're going to see which one of these answer choices equals that same thing. So, not surprisingly, I'm going to pick 2. And so I'm going to do 10 times 2 to the 6th, or negative 2 times 2 to the 3rd. Your calculator, again, can do this for you. On a calculator, just be careful. You've got to get the entire top part of your fraction here solved before you can do this dividing bit at the bottom. In fact, it's probably best to just have the calculator tell you, let's see, 2 to the 6th power is 64 times 10 is 640. And then do the bottom part. So 2 to the 3rd is 8 times 2 is 16, negative 16. And then 640 divided by negative 16 is negative 40. So when we chose it. Well, I chose it. You might have wanted a different number, but it's my video. Too bad. When we chose A equals 2 and used the calculator or otherwise came up with a numerical value that this whole thing equals, which in this case is negative 40. This right here is negative 40. Now all I have to do is run through the answer choices, plug in this positive 2, and see which one of these is going to give us negative 40. And the nice thing is, all of these right here, if I plug in a positive number, there's no way they're going to be negative. So once again, putting in a nice real live number helps us see why some of these answer choices could not be right. And so I'm only given these 2 choices. Let's just take them in order. 2 squared, I'm on this one on A. 2 squared is 4 times negative 5 is negative 20. That's not going to work. 2 to the third is 8 times negative 5 is in fact negative 40. That's what we need the answer to be, and that's the answer choice that is correct. And just one more minute. I said, well, if you try a number like 1, weird things will happen. And here's an example right here. If I plug in 1 for A here instead of 2, I don't even have to know what this equals if we make it 1. I just want to show you that 1 squared times negative 5, well, 1 squared is just 1 times negative 5 makes it negative 5. And 1 to the third power is also 1, so times negative 5 would still be negative 5. These two answer choices would be the same. That's what can happen when you use the number 1 as the number you choose to plug into one of these types of problems. And 0 is not going to work at all, because if I plug in a 0 down at the bottom, we'd be dividing by 0. That is not allowed. You cannot divide by 0. If you do, the math police come to your door. They come at midnight and they do not knock, ladies and gentlemen. So do not mess with the math police. Do not try to divide by 0. And we want to avoid picking numbers that make the bottom number of a fraction 0 when we are picking our own numbers at any time. You just can't do that. So I chose a nice, easy to work with number 2, and only one answer choice worked. So at first glance, this looks like one we would not be choosing our own number, because there's numbers right here. But pause for just a second and read the problem. And I'm hoping you've done that now. If not, maybe the rest of this won't make any sense. The problem is asking, how many times larger is one rectangle's area than the other? So these numbers are about comparison. So sometimes when you have answer choices where you have, in this case, numbers, meaning 5 times as big or 10 times as big, or sometimes fractions, half as large, 1/3 as large, or percentages, 20% bigger, 30% bigger, that kind of answer choice, you can put your own numbers in this case, for the rectangle, and see what happens in very specific terms, and then go from there. Here's what I mean. I'm going to draw 2 rectangles. I don't really have room to make one of them 5 times the size of the other. So I'm just going to make one bigger than the other. The big one is A, I believe. I want to double check that, and then B is the small one. And A is the one that's larger than B, so we're going to pick some numbers for B. I'm going to say that this is 2, and that is 4, just because it kind of looks like that. And you would have to remember, and actually on the HiSet you are given a little formula table, that the area of a rectangle is the length times the width, sometimes called the base times the height. And in this case, the area of this is going to be 8. Now, each of these sides, according to the problem, needs to be 5 times as large as the corresponding side over here. So this one corresponds to this. 2 times 5 is 10. And then 4 times 5 is going to get us 20. And so the area of this is going to be 20 times 10, or 200. Now, we need an answer choice that makes sense. Well, what does the answer choice stand for? How many times larger is the area of A than B? So we're just going to take B and multiply it by each of these and see which one comes out right. 8 times 5 is 40. Now, I believe this is the trick answer. I'm circling it because I think that's what they want you to pick. You're thinking, hey, the sides are 5 times as big. It's 5 times as big in area as well. That's not true. Let's try the next one. 8 times 10 is 80. That's too small. 8 times 20 is 160. 8 times 25 is 200. This is our answer. The area of this rectangle is 25 times larger than the area of this one. All right. A little bit more complicated problem, especially if you're not familiar with function notation, but function notation goes all the way back to, I don't even know what grade they do it now, where they tell you about function machines where, hey, if I put this number in, a different number comes out. That's all this is right here. Function notation just says, hey, pick a number x, and whatever number you pick for x, you're going to do this stuff to x, and you're going to get a different number out on the other end. But then they don't even ask us to try the x. They're going to ask us to try this x minus 1. Now, we haven't picked a number for x yet, so this is all very abstract. The way they want you to solve this, the algebra way, is to replace x here and here with x minus 1, multiply it all out, combine your like terms. It's going to end up being one of these. If you already know how to do that, you probably don't even need this video. So, what we're going to do instead, to make things crystal clear, is we're going to pick a number for x, and I'm going to pick my old standby 2. All right, so now what we have to do is answer the question. Now remember, we're asking ourselves, what kinds of problems can we pick our own numbers for? And again, it's problems. One type is problems where there's variables up here in the question, and the answer choices also have variables. That means we can pick whatever number we want for x, and as long as we get the math right up here, when we plug that same number in for x down here, we should be good to go. So the question is, what is f of x minus 1? That is to say, if we picked a number for x, and instead of trying this on x, tried for x minus 1, what would we get? Well, I picked x as 2. So x minus 1 is simply 1, because I picked 2 for x. Okay, this was my choice here. So x minus 1, it follows, is going to be 1. So again, the way these choose your own number problems work is we answer the question first. The question was, what is f of x minus 1? We picked 2 for x, so f of 2 minus 1 would just be f of 1. And again, if you're not familiar with the function notation, f of 1 just means we're going to try a 1 in the place of these x's here. And I'll write it out just to make it clear, but the math's fairly easy. 3 times 1 squared is going to be 3 minus 1 is 2. Now, I'm sorry that the number we picked also happens to be the number we got when we did the math it asked us to do. That's just a coincidence, but that's what we're going to be looking for. Down here in the answer choices, we are going to be plugging in not 1, but 2, because what we see here are x's. Our x was 2. The question asks, what is f of x minus 1, or what is f of 2 minus 1, or 1. We got our answer here. Now we have to see which one of these gets the same answer when we plug in 2 for x. And I'll just run through them real quick. 2 squared is 4. So all of these first terms are going to equal 12. And then here, minus 7x. 7 times 2 is 14. So 12 minus 14 is negative 2 plus 2. That's going to equal 0. And again, you've got your calculator. You can use your calculator for this. Now we're going to try it for this one. Again, that's 12 minus 14 is negative 2 plus 4 is 2. Now the rest of these, if you were to run through them, and it's a good idea to do that if you've got time, because occasionally you have bad luck and the number you pick makes more than one answer choice work. And these are pretty quick to go through. These are all 12 because we already figured that out. These are all 2, so that's 12 minus 2 minus 4. That's going to be 6. 12 minus 2 minus 2 is just going to be 8. And 12 minus 2 plus 2, it's just going to take us right back to 12. So none of these three are correct. So our answer choice B is going to be the right answer. So I could give more examples. I hope you get the basic idea, especially if you're a teacher working with students. The idea is they need enough points to get that 8. And this is a way they could pick up an extra point or 2. And if you're a student, practice this. Even if you know these techniques on a problem like this, I mean, if you know how to solve it the right way, practice these techniques, because there might be a problem or two where Putting your own number in is going to make the problem easier to understand and may be the only way you can in fact solve it if you don't know how to do the math. So practice this as you do practice tests, and good luck.